So, good evening, dear participants. Welcome to the last session of this machine learning module. So, before starting today's session, we have some announcement. First, kindly note that the session for genome-wide association studies will be at 6 p.m. Indian Standard Time, 1 hour earlier than the 7 p.m. schedule. So, last 5 session will be around 6 p.m. Second, we have uploaded some prerequisite video for GVAS section in the drive link. So kindly go through these sessions. And third, we have uploaded all the video recordings till date, and the project session of Python based module will be on 16th. That the workshop is scheduled to be finished on 15th, but the last session project will be on 16th. So kindly note the changes. I will also mention it on the WhatsApp group. So now I am handing over session to sir. Over to you, sir.
Good morning to everyone. So let's start where we have ended yesterday. So yesterday I mentioned that we'll talk a little bit about the definitions, or you could say the parameters about measuring how our model has been built up. So let me share my PPT. I just have included one slide. So, okay. So in the classification model, mostly the parameters are actually is measured into three. So just to make you understand, it's the actual sample. So the actual sample could be divided as a positive sample or negative sample, depending upon your question, what you are taking as a positive or negative. So just mention is something like, if your interest of the if your interest is something should be positive, this is positive, and what you don't want, it should be negative. So this is actual class of positive and negative, and you have make the predictions like positive and negative. So if it's actually positive and it is also predicted as a positive, so that means it's true positive. But if it's actually positive but it has been predicted as negative, so that means it's a false negative. And those positive predictions which are actually negative are known as false positive. That's a type 1 error. And if the negative has been predicted as negative, that's true predictions, that's a true negative. So these are four kind of, you could say, confusion matrix or something, whatever you call it, will be framed. Okay, so true positive, true negative, false positive, false negative. So sensitivity is something when you are predicting actual how many of you, I mean, from the whole of the positive sample, how much has been correctly predicted as a positive. So that is sensitivity. So sensitivity is something which is dealing with the positive data set. So how many of you, how many of the samples have been predicted as a positive, which are actual positives from the group of actual positive samples, are known as sensitivity. And similarly, specificity deals with the negative sample. So how many are actually predicted as true negative from actual, you could say, negative samples. Okay, so this is specificity. And accuracy is something where you have made a correct prediction both for the positive and the negative. So that is true positive and true negative. So yesterday we have discussed, if sometimes sensitivity is very much but sensitivity is less, how could be the accuracy will be somewhere in between. So if you carefully look at the formula, you can get it. If this value is something around 95 and this is something around 50, and overall this will be common. I mean, this let's suppose this is 100 samples, so 100 it will be same. So overall the accuracy will be something around 70. So if I have sensitivity and specificity, still accuracy will give a better example, better results. So, and this is very less used, but sometimes people used to give the precision, which is actually the true positive coming from the true positive and the false positive. So how it has been predicted with this. So this is sometimes precision. Is also mentioned in some of the literature. Most of the time you'll get sensitivity, specificity, accuracy, and there is something MCC, which is just a formula based on long formula. I have not mentioned it here. So this is all about the stats what we have forget to mention yesterday. Now the next thing is what I promised you to we have done with the classification. So I promised you to go with some regression model building, and I said that we will go with some genomics data. So I tried to do on the genomics data. I have some genomic data, but the problem was even in the mid steps were taking at least at each step I have to execute it. It takes something around 30 minutes, 15 minutes. So if I'll run the whole code, it will ask 2 to 3 days to run. So that will not be the fruitful. So I'm just giving you a glimpse of my data, what I wanted to execute. So you could see this data. It is a very long data. Even it cannot be huge data. Even it cannot be included or loaded on the whole Excel. So this is just to give you some examples. So this is the data coming from methylation platform, methylation array sequencing platform. So and where we want to correlate aging of the sample with the methylation level. So these values, this 0.02, 0.05, 0.6 is something about the methylation level. It is in the percentage. So 100% means 1, 0% is 0 something. And this is some age into this. So our motive was to relate by reading these features to predict the actual age. So this is our motive, but it will take a lot of time. So it's not a good idea to show you to demonstrate the machine learning onto this. But we will go with some little data. We'll go with some, some very short data, but it will be same. The parameters, or you could say the numeric, it will also be a numerical data. So the steps will be same. So I'll demonstrate everything with a shorter data set. We'll create a data set, the shorter data set. All the steps will be same for whatever you will do on the sequencing, whatever your high data is. So this is just the difference will be only in the data set, but the methodology, the steps will be same, and you could execute that steps on whatever data you want. So let me share first my screen to you. Okay, so I have opened a new kernel. I have opened a new Jupyter kernel for this, and we should now start coding. And because it's a Monday and we have a limited time of 1 hour or something, I will try to extend it as much as possible. So we'll move forward with some very fast steps. Okay, so right now, like, I'm just going to do. So first the steps will be same. You have to import a lot of things. So let me copy the import thing. So this will be same. I mean, you have to import a lot of things. Import operating system, import pandas, matplotlib, numpy, sklearn. You have to import it. So we have already imported these steps, and I am also pasting it into chat box. Okay. So okay, so this has been executed. As I said, whenever it will be executed, the number will be changed here. Now I need to main model. So from the data set, I just want to import a function which is called make regression. So there I will create a random data set just to demonstrate you. But once you have your own data set, you don't need to import the make regression data set. You will directly call your CSV file here, and then you will split it using the pandas function, how you want to split it with like X and Y, what I have demonstrated yesterday. And from the sklearn model selection, we have talked about this yesterday only, train test split, so that it will be, the data set will be split into training and testing. So this is the common step. And now I'm going to generating a regression data set. Okay. So this is the step for it. Let me explain to you. So what I am doing, because I don't have any, I didn't have any data set on my system. I'm not copying it somewhere. I'm just creating a data set which will be equal to what I have shown you into the Excel. The same numbers and same thing. So I'm just creating X and Y. So it will be a regression data set. That means a numerical values. So number of samples I have taken thousands. So I means so overall sample in this data will be 1,000, and features for each sample features I am taking as 100. And this I have given an informative means something. So from the 100 features, I have just here I have selected that 10 features should be the informative and 90 are redundant features, or they are not important. So this I just have given for you. But once you have your own data, you have to see how many are the informative or not. So the stuff will be same, but right now we know that we are just creating the data set and we know it. So that will be easy to explain the things later on, to execute the things. And there is something called noise in the data set. All the time you will get the data, there will be some noise, so you have to deal with it. So again, here we have implemented some noise, and the random state I told you just to, so that whenever I run the this program, so all the calculation behind the this command should be the same. So right now, okay, x and y has been created. So let's see what is x and what is y. So you could see this. So this is something x, because it's in the kind of array. So it's something around 1,000 samples. So this is given 3 of the head and 3 of the tail samples. And these features are because dot dot dot, that means something around 100. Okay, so this is regression data set coming from numerical values. And it's my humble request, everyone please mute themselves. And this is something about x, and what we are going to predict will be the y. So this is something, some values which want to predict is the y. Okay, this is all again the 1,000 values. Yeah, I'll pass the code. Okay, I just forget to paste these 2 steps. So now we have got this. We have got this random state, and x and y data set has been created. Now the next step is that the same thing what we have done yesterday. We are going to split the data set into training as well as testing. So this is the same what we have done yesterday in the classification. Most of the stuff you will find that is common. So again, I am just splitting the data set into training and testing. So all the x, which is actually the features, have been split into training and testing, as well as what we have to predict, the value y has been split into training and testing. So function this we have already called in the initial step, print test split. So again, we have called that function, and then xy. And here what I have chosen is, yesterday I told you to go with 80-20. Right now I just choose to go with you could say 67 and 33%. So it's 1/3 we have taken into the test size. So let's execute this. So if you find this train, you will see this has been some less values. And if you copy the same function what we have copied here about knowing the description of the data set or feature, so this we have already done yesterday. So now you could see that because there's a big data set, it is coming into this. So you don't get how many rows are there or something, because it's more than 1,000. If I copy this, you will see the shape. Let's first see the x of the shape. So this is 1,000 into 100. We have already talked. So now we have in the training, we have 67%. So it should be around 70 or something. It's 67. So here this command is useful, what I have demonstrated yesterday, but at that time it may not seems to be useful. And similarly, if I'm talking, I want to check my test shape, so it should be around 330. Okay, that's fine. Everything is fine. So I just have checked my all the training testing has been done with the in correct pattern. So yeah, I could type this. If you want to print it into your final code, you could type this and you'll get it. Its training is 670 into 100, testing is 330 into 100, 330. Okay. Now, so this is about the data set preparation. We have done it. Now, the next step is we are going to, because in the iris data set, there was just 4 features. So we haven't done the feature selection or feature extraction, but here we have 100 features. So that doesn't mean all the features will be important. So initially you could do, you could make a model using all the 100 features. That's not an issue. You can do it. So like what we have built yesterday, on the same manner, you can build it on all the features. But what if the 100 features are not useful? There are few features which is equivalent to the 100 features. So that means we have to select the features. In the regression data, there have been methods like correlation feature selection, mutual information feature selection, and a lot. So let's try with one of the method, that is correlation feature selection. So we will select with the Pearson correlation coefficient. If it's, I mean, if they are, the features are correlated and they have the property so that to exclude other features which are of non-relevant pattern. So we'll select only those. Okay, so for this we have to first we have to apply one of the function. Just give me a minute. I don't know which. Okay. So initially I am doing it on all the features. So this is fs select k best score function. This is some of the function of the regression k all. Okay, so this means this command I have pasted. So it is selecting k best. This is a regression feature, what I have called correlation features for this. This is select k best method is there. And now we are learning the relationship from training data. So that means we are going to fit it into X-train and Y-train. Okay, this is another crucial step. And then we are transforming the X-train data as well as X-test data. This is, we are transforming the X-train data and X-test data, and then again test data also we will transform. And now we want to return some values about what it is done into using the FS. So okay, and let me execute this. What? Select k best is not defined. I have not called the select k best in the initial step. So let me first call few functions. Okay, so because it I have not called these functions initially, so that was error. Okay, so if I execute this X-train fs, I get. So what it is done, we use some select key best method as well as F regression. So that means we are using the correlation feature. So whatever the features are, it has transformed by using this function into some X-chain fs and X test fs. So if you compare it, so whatever the exact feature value, it has been transformed using this method. So the values have been transformed, and now it will apply onto apply the machine learning onto this. So just paste it here. Yeah. I have pasted this step, and I think initial steps also I have, that was not much important. So this have been so this data transformation has been done at this step. Okay, now the next what I want to do is I just want to score these features, so that will be easy to understand how this are how this is good. I mean, how much we have to select, because if it's 100 it's fine, but if it's what if it's 1,000 or like 7,000 or something what I have into Excel, what I have represented, that was more than 50,000. So how you are going to do this? Let me check whether I have. So now you could say that each feature, so feature 0, 1, this will be till 99. Okay, this is still 99 for starting from 0 to 99, that's 100. So it has scored them. It has scored. So this is the value 0.0, this is 1.01, this is 9.101, and something like that. So whatever this FS score has been calculated here. So from this we could know how many are actually important. But it's tough to find out these features. So one way could be I just export it into the Excel and then sort it based on values A to Z or Z to Z, and then select how much I want. Another way could be let me give a visualization example, so that I just have plot a graph into using the same function. So right now I'm just plotting a graph. Pie plot I must have not defined. So let me call this pie plot function again. Now you could see this has been the same what we have got in the last step, where we have scored the features and printed their values. It has been plotted. Name FS is not coming, that means you have not, name FS is not coming means we have not, you have not imported this select K best. You have not imported this. So now we could see here we could see this graph. So that means if you easily analyze this graph, you could say, okay, there are just few features which are important, and the rest, these are not the important feature, or you could say recursive or non-important features are, or you could say there have been some noise also, because we have given 0.1% noise, and we know how we have made our data. We have already given that there should be something like 10 is important, so we have got 10 or something. But if it's a random data set, so you have to do this step, and you based on your concerns, you have to select how many features you want. So so we know here we just have given the 10. So you will build a model onto 10 features. So now what will be the next?
Sir, apart from graph, based on any numerical values like feature selection or threshold value, we can say these are our important feature selection features.
Yes. So here we have applied the correlation feature selection method. So you have to give what method you are using. So here when I have typed this select K best, so it's it's already, this is example of correlation feature selection method. So there are some other example like mutual information method, where it will mutually correlate two features, and then first to second, then first to third, and then. So these are the methods. So here we have taken the correlation feature method. Based on the correlation, you have to give some cutoff. So it depends on what cutoff you are using. So the ideal steps are to be what we used to do. Okay, we know that these numbers are coming from 0 to 100. So I'll make a cutoff something around 90, and we'll see how my model is performing, and then I'll try to do something on the 80. So this could be a one way. Another is a very grid search method, which is actually not useful if you have some computational limitations, because that what it do, it automatically select all the combination and apply the cutoff. So that needs some computational thing, another thing. So that is also applicable, sir. But most of the time people don't rely on the grid search or the recursive elimination. They used to apply either mutual information or the correlation features, and then they used to take a cutoff based on their understanding. Okay, if I'm putting this cutoff at this, what values I'm getting, how my model is performing, and then we choose the best method. I hope I'm clear. So there is one chat box, name error FS is not defined. So those who have learned fs.score, because they have missed this first step where I have defined this f regression and this step. That's why this error is coming to some guys who have pasted into. Yeah. Sorry, your voice.
We are having some data. Okay.
Ma'am, your voice is not coming to me. Yeah, right now it's audible. Yeah.
Okay, just a second. Am I audible? Okay. Just like if there is a table, we have a data, and that data we can do these functions, right? But can we take so like you have created a data set, and then on with this we are doing, can we work directly on the database that we are already having online database?
Yes.
In the
bioinformatics? Yes, obviously you could download the data and just upload onto your onto this. I mean, like I have created that. You have to just import.
But the data, if the data is very huge, then also it will work.
Yeah, obviously it will work. So what the data Excel I have shown you, it was something coming from the 20 mouse sample and having each sample is having around 40,000 probes. So that's a huge data. But if I have demonstrated that to you here, each step what I am pasting, it will take a few minutes to few hours. So that will be not ending, session, because all these stuff what I am doing. No, you could do. Yeah, you could do this. But what the steps I will complete within an hour, it will take 1 week. To,
No. That I understand. Yeah. I just was worried like a huge data can be worked upon.
Obviously, yeah. Scikit is very good. Jupyter is enough if you have something around 8 GB system. If you have 8 GB laptop and if you have these libraries, that's enough to do. It's just you need 1 week to 10 days to complete all. That's what I'm talking about. So, I mean, it's good enough to invest 1 week to have some good results.
Okay. Sir, again I have query, sir.
Yeah.
Salman sir, actually, maybe you have the more than 1,000, like more than 200 variables, features. So that is we find easy to like based on the like numerical value, like by plot. But I have the only limited, like mostly the medical field, because I use in data, basically surgery or like medicine. So there is very few, like limited, maybe 12 or 15 variables. Okay.
Yes.
On that condition, sometimes what happen, maybe value will be near about minimum like 0.001, 0.002, 0.00, even like that. So those conditions is very hard to find, like which are feature selection is very important for that.
So in most of the cases you will see in the paper, I may be wrong, but what I understand, in most of the time people use all the features except if someone is negative, has the negative impact. So most of the time what I'll do, I may be wrong, but if I have something like data, what I'll do, first I'll build a model based on using all the 15 features. Then I'll go with the 14 feature, 13 feature, 12 features, and so on. And then I'll see whether what I have achieved maximum with all the features is related to somewhere around 11 or 10 or not. If it is something, there is, let's suppose that my 14 features have better accuracy than the 15. So that means there is some feature which is having the negative impact. So I'll remove that and I will make a model something on the 14. So this will be my way of working. I'm not sure it's correct way or not, but I'll go with this. I'll go with these steps in this type of problem.
Okay, sir. Because actually, our team, I haven't did, but doctor is the pathology. He did some cancer data, so he was looking on that. So that he come to me like, how can be the help regarding this, which are important feature selection. So that I am not very familiar, but I do some little bit machine learning, sir. So that was very problem for me. Like out of 12, because there 0.001, 0.001 was like that.
So you have to first, you have to go with like I have to work with that project. First, I'll go with the correlation feature method. Then I'll try to apply the mutual information, and the steps will be same. The correlation already I'll try to go with 15:1, or you could say this is known as recursive elimination, where you first apply onto the whole feature, then you will remove one feature, then remove 1 1 1 1. That will be with 15 combination. Then you will remove 2. So that will be 15 into 15, 225 combination. Then you will remove 3. So this is the recursive elimination. So it will take time. It will take much better computational thing. But so you will get all the combination. Then you will analyze on which conditions you are getting the maximum accuracy or the maximum results. So this will be the step. So obviously it's not a one step go, but this is how I will proceed. So same thing I will do on the correlation. Then again, I will go with the mutual info regression method. There have been 2 to 3 methods. Then I will try to apply the weight search and other things and see which is actually coming with the best. So might be I have more than 2 or something models, and then I see which model is actually outperforming the others.
Okay, sir. Okay. Thank you, sir.
Then so we have already created the data set and know about the features by looking at values as well as these graphs. Now we are going to build a model. Okay. So for building a model, we have already seen yesterday, like in the classification, but this will be same here also. So this is just let me call something. There is something, so many background noises. So it's my humble request, if you don't have any genuine query, please mute yourself. So this I have imported because I am just going to go with, because we just have left 30 minutes. So I'm just going to be with one model, linear regression here, but you could go with the logistic regression and other regression methods, whatever are in the regression. So we are just going to do with the one step. So for the another method, it will be the same. You just have to call that particular model from linear model. If you want to go with the elastic net, if you want to go with the ridge regression, whatever you want, you just have to call that, and all the other stuff will be same. So we are just going with the linear regression. So let me paste it into the chat box. And this also. So I'll see this once I have called this model. When I will type model, I will get, okay. So that means linear regression has been called. So if I'll import something here also ridge, so it will be model like, let me show you. It's not too much thing, but in the final stuff, we'll go with just one. Let's suppose that I have copied here as ridge. Yeah. So I just have copied here as a ridge. And if I call model as ridge. So now if I'll and if I'll call as model, I'll get ridge. Okay. So this is how you could call other models, other methods. So each problem you have to execute so many models and see which is actually coming with the best thing. So again, finally, I'm just going with the linear regression. So linear regression. So I just have shown you how you could call other models. So in the regression also there have been so elastic net, linear regression, logistic regression, and few others which I don't remember right now. So you could execute all those models, all those algorithms within the same syntax. So now I have called the linear regression model, and then I'll fit whatever the values we have got. I'll fit it. So model fit X-train. So on the training and testing data, it has, so it's a very less. So you have seen that it executed within few seconds. So that means all the values have been fitted here on this model, and we'll evaluate what we want. So on the testing data is going to predict the values. So we have got this phi hat. So now it has predicted the values here. All those 100 values have been predicted what the actual one is related to this. Now you could see how our model has been built up. So we'll see the mean absolute error is an example, is because this is not the classification true, positive and negative, it's something like values. So we have to go with R square or mean absolute error, and RMSE, which is almost all these three are the same. So you could go with one thing. So I'm just checking with MAE. What is my MAE? So it's something 0.085. That means it's something good. It's a good model. It's predicting with, because the error between y test and y hat is not actual data, and the predicted data is not much mean absolute error. So that is something around 85%, or in other word, it will not be the correct way, but we could say it's around 85% accuracy. It's not the correct way, because in the values we evaluate our model based on the MAE or R square. So we have implemented its MAE around 0.085. So this is all about building this model. I mean, we have called the model and we use all the features right now. Next, what I will do, just give me a minute and look at my code. So right now what I have done here is actually, I have built the model onto the all the features. If you see here T is equals to all. So this 0.85 has been developed on the all the features. Now, as I know that I have already shown you that 10 features are important. So let's make the model with 10 features and see whether this is achievable or comparable to what we have done here. So we will configure it with 10 features. So the step will be same here. You just have to modify your code and select 10 only here. So what I'll do here, I'll choose the value as 10. Okay. And then all the steps I have to do it again. So X-train, testing and training has been done here. I mean, fitting the model has been done here, and then I'll build the model fit. Again, I'll fit my model onto this X-train and Y-train plus what I have changed here. And linear regression I have called again, and then we'll again predict the value or evaluate the model. So, and then I will check MAE, how it is, how are the MAE. Okay. So now you could see this is actually not a good model. This is MAE is 2.7 as compared to this. So that means there have been some features which is giving the negative impact what we have selected. Okay, so that means the top 10 we are selecting is not, it's other way around. The rest 88 is actually giving rest 80 is actually giving a good example. That's how you will proceed with this. Or you could say on this data, maybe any other method like mutual info regression or something will work on. So this is in the same way you will go on.
Dr. Salman, is it possible to share this Python file, this one as a practice for practice, or otherwise we will share the code in a separate?
I'll share the whole code in a separate. Yesterday I didn't get the time, but I'll share the whole code. So that's how they will get an idea. Let me paste whatever I have.
Sir, 2-3 steps you can share because I have continued coding with you. That's why I'm there. So just 2-3 step I'm missed from. I think you have to copy that. We're taking
Yeah.
the I'm also coding.
Yeah. So let me just, this is my whole code I have. This is how you will write. So if I'll go with this because I have defined feature selection, then calling, and so that will be tough to understand. So this final file I'll share with you. So right now I am executing each step and calling another thing. So this final file you will get. So how we are getting it. So you don't have to worry for this. So in this way, you will get the mean absolute error like 0.27, 2.70. So but that is, in this data, what has happened when we are removing or taking the 10 data, that means it's the other way around. I mean, those 10 are not getting that good example. So the remaining which are having less value, remaining 90 are much better. So let's go with in between 12 to 99, 12 to 90 what we have, and we just select. I'm just selecting a random number as k is equals to 80. So what it will happen? What will happen? Let's see. So I just have checked as 80 and will build a model. So what it will do, it will take the 80 that. Okay. So now you could say when I select the 80 models, it is something around what we have taken all the other. So that means we have to go, we have to see this data as the other way around. So the top 10 with the highest scores are not actually giving the positive feedback, but it's a negative feedback. So we have to go with the other way around. So the remaining, except those 10, the remaining 90 are actually making it somewhere good impact. So we are receiving this MAS 0.085. So that what will be the answer. You have to, tune this value, tune this K value, what you want. And you have to select based on what the graph or what the values in the correlation feature method you have got. Similarly, you could go with some other, maybe on this data set, correlation feature is not actually working. So you have to go with mutual information method or some other method. Please paste the code because I'm going with you. Okay. So we have done with the MA first. Then I just have select the top 10 based on my graph. What I understood with this, okay, top 10 should be the good one, but it's other way around, and it's not giving the good impact, but actually it is giving the negative feedback. So that means our model's performance will decrease. So then what we have done, we just have changed this K as from 10 to 90.
Can you copy from the Ridge regression too? Yeah, the logistic regression.
Yeah, you can do anything. I mean, from here I have taken the linear regression. Maybe we just call the model as a ridge.
This is I did, sir. That's model regression, model dot fit X train. I don't know. My is coming error, sir. That's I'm confusing, sir. Go up, sir. Just go up, sir. I had. Yeah, this is
okay. Yeah. So first I have executed the ridge. Then again I have executed the linear regression because I am calling the linear regression only. I just have just to demonstrate how we could call some other models also here instead of linear regression and bridge. Okay. So now when we have selected the 80 features, we have got the MAE as something around 0.085. So that means all the 10 what we have selected is actually making the negative impact. So we have to remove 10 and select other 80 features. So this is how we make, this is how we develop the model. So let's go. Let's see some other steps into this. How we could evaluate.
So there is a gentle request, please kindly behave properly and don't unmute yourself unless there is a query. Because we will share this video recording with all our participants, you people. So it will affect the quality of video recording and also the efficiency of this session. So kindly cooperate.
Okay, so we have done this, and another way could be, like I said, we could go with, grid searching instead of doing this each step. So I mean, we understand that it will be less, it will be something around 90 or what we have got. So let me just copy all the steps in a single code and explain to you like this. This is another way, but if I'll type each steps again and explain, so that will take so much time. So let me open one new kernel, because I have to wind up the things. I have planned so many things, but it's not possible to cover in an hour or 1.5 hours. So what I have explained here, I hope it's clear to everyone. If there is some doubt, you could ask. Because now I'm going to the second code, which will be similar to like this only. So if there's some error, I mean, the basic idea you understand or not, how to go with feature selection, how to execute that, how to build the model, and then read your model in terms of MAE. If there are any query, you please raise your hand, unmute yourself and ask. Okay, that means there is no query related to this. So let me move to second code, or the second way of doing the things, where we could do, instead of doing one by one, we could do by grid search. So few steps are common. So let me paste this into the chat box. So they could, okay. It's not copy paste. I don't know why it's not pasting in the chat box. It's not, you could use the same terminal, or you want to use a different terminal. I think there is some limitation in the chat box to some words, because it's a large wording on the clipboard, so it's not pasting. So maybe I have to paste it one by one, or maybe few lines. So first let me explain the code, then we'll see how we are pasting. So now what I have done here, as a from sklearn dataset, I'm importing make regression, repeat k-fold, select k-best, mutual info regression. Initially, what I have talked about the correlation feature selection. Here I am talking about the mutual info, which is another way of feature selection. So just to give, because these two steps I wanted to explain, but we will run out of time. So this is another way, mutual info regression. Initially it was correlation feature selection. And again, here I'm calling the linear regression. And when I'll do it heavily, I'm not going to check on each feature. I make a pipeline. I'll make a pipeline and run my code, and will do some other work. So it will run in the background. So I just call a function as a pipeline. So whatever I want, whatever condition I want, I will define it, and it will automatically run in the background, depending on my data, maybe for 10 hours, 20 hours, 15 hours, whatever time it will take. Then I'll select with the grid search CV. So this grid search means it will automatically make a grid on each features and execute one feature, and remaining other similarly, then execute two and other things what I have mentioned earlier. So this will be the grid search function. Same data set I have prepared 1000 and feature 100, informative, noise 0.1, random state 1. Okay. Then I have defined the evaluation method. So it's a repeat k-fold, what I have called here, and number of split. Like yesterday, I told you about the 10-fold cross validation or 5-fold cross validation. So again, the 10-fold cross validation will execute here. The model I called here as a linear regression. FS select k best.
Sorry, sir.
Yeah.
Validation, how long, means like you're saying speed 10 times. So maximum how number can we, how many number we can give?
So most of the time you will see in the in the book, in any machine learning theoretical book, you will get only, repeat fold split, you will get either 5-fold cross validation or 10-fold cross validation. This is true. But in few research paper, I have found that because they have the limitation of their data, they have done with 3-fold cross validation. So these three numbers I came across, but theoretically, I mean, you could split into the 7, you could split into the 6, you could split into the 8. Theoretically, it's everything is possible. You could split on the 11, 12, whatever you want. But in the textbook, I just got 5-fold cross validation technique or 10-fold cross validation technique. In some paper, I got 3-fold cross validation technique. But theoretically, you could, theoretically you could do what I assume you could do any.
It is depend upon data, like volume, like how much big data.
So if it's a big data and you are splitting into the huge number, that will be obvious, because if I have just 10 data sample just coming from the 10 mice, so I can't do into the 10 split, because my testing will be just one number, so one is nothing. At least I need 3 to, test something to get a mean value or something. Yeah. So the 3 split what I am talking about, because they have the limited data, that's why they have done the 3-fold in one paper. Otherwise, I just came across the 5-fold or 10-fold cross validation. So we have again done this stuff. What we have, this have been discussed yesterday. Then I called model linear regression. Again, I am selecting this FS select k-best score as a mutual info regression. And in this one, I have called as a mutual function f regression. This is for the correlation. So this is f regression. Here I have called some other function like mutual info regression. This is another method. And here I've defined the pipeline, what I have called here. So what it will call, I just define 2 functions, cell as fs and lr as model. So this fs will come here as a cell and this model will come as in lr, because this is what I have done. You could change, you could write it with some other words, that's fine. Then I'm defining the grid. Grid is a you must have came across with the dictionary function of the Python coding. So here I'm using the dictionary function. Grid is equal to cell and k. So what it will do, it will call fs first as well as model I in the range of x dot shape. This means we have 100 features. So I'm just taking from 100 minus 20, that is 80 to 100. So from 80 to 100 I'm giving. You could change this number based on your understanding. So right now what I'm doing, I'm just want my features from 80 to 100. So the number from 80 to 100 from the among the 100. So it will take less time. That's why I choose you. I could choose from the 50 to 100 or 40 to 100 or even whole, all the 100 samples. So that grid search will take time to execute. But this I think will execute within 2 to 3 minutes. So I have just put it like this. Grid search CV pipeline grid scoring. So I'm just scoring with a negative mean squared error and it's equals to jobs minus 1 CV. I've called it. So it will fit the result and will fit the best image and configuration. And let me execute. So I think it will take 3 to 4 minutes to execute.
The noise equal to 0.1 means what?
Pardon?
So here in defined data set, you have defined noise as 0.1. Could you please explain
this? This is just my assumption, because what I assume that from whatever platform you are taking some data, there must be some noise. So you have to, in the pre-processing of the data, you just remove that noise. So just to make, because right now I'm just generating the data set. It's pure random generating artificial data set I'm creating. So I assume in the real time data there is something noise. So you will feel, because if I'll not define the noise and other things, whatever I'll do, I will get the maximum accuracy. Just to make it realistic, I just have defined the noise. If I just remove it, my performance will be better, my data set is better. It's not a very important thing, it's just that I defined it. It's fine. So I think it will take time. Maybe yesterday it depends on the speed also, not speed and other things. So yesterday when I have executed, it takes around 10 to 15 minutes or so. Let's see, let's wait for this. what it comes. So till now, you could unmute yourself, and if you have any specific query, we can discuss it. And when this file will execute, we'll discuss what result we are coming with. Okay, so if you have any query, we can discuss for the next few minutes.
Hello, sir.
Yeah.
Sir, in the evaluation method, what is the meaning of the random state? You have given it 0.1. What it depicts?
Not in the random state, it's 0.1.
Evaluation. So what is the meaning of it, the random state?
So random state, I talked, you just define it because you know what happens. Let's suppose I have 10 something 10. I just have 10 numbers or 10 objects, and you ask me to pick one. You just ask me to pick one. So I choose to pick the fifth one first. Okay. Then you ask me to pick another one. So I'll pick the seventh one again. Okay. But if I ask you to pick one, maybe you will pick the fourth one and then eighth one. So your random state and my random state is different. So when I define the random state as equal to 1, so that means I'm giving the command to my program. Each time it should pick whatever it is picking in the same manner it has executed. So like first time I have picked 1 as a first sample and 7th as a second sample today. Tomorrow if I have to pick, again I'll pick the fifth one first and the seventh one first. That's why I have defined the random state as 1. So it means 1. It could be 42, it could be anything, whatever you want. So in the same manner it will pick. So maybe if I define the random state something like 30, so it will pick the second one first and the ninth one first. So if I execute this program again some other day, so similarly it will pick the second one first and the 19th one first. If I'll not define this random state, maybe next time I'm executing the program, or if I'll submit this program to anyone, so because the random state is not defined, so it may pick something randomly because it's not defined. So it will pick randomly. So the performance of the result will be little bit different. So it may be something, if I'm getting 96.5, so it may be 96.3 or 96.2. So, you know, whatever you are doing, it should be a replicative. It should replicate and should give the same result, what I have executed and what you are executing. If you are repeating whatever I have done, so it should give the same what I have achieved. So that's why I've just defined the random state. I hope it's clear now.
Yes, sir. Okay, sir. Thank you.
I think it's taking much time. Yeah.
Sir, actually, you're talking about the data pre-processing. That is, you have to do the before data splitting, or like after splitting, we have to do that.
No. Data pre-processing means data pre-processing is another step, like what the Excel I have shown you. Let me again show this. Okay, this is something coming from the array platform, from methylation array platform. So it's an array sequencing array data. So, but if someone has done with the sequencing, so this is not the exact value you get. So what you will get something like .idat file, which I can't access on my system. So you have to do some normalization instead. You have to convert those values with all the platform from wherever the platform is coming. So you just convert it into something, because it's a light intensity they carry it. So you just apply some methods to that and then convert it into the final value. So this is the file is coming after the normalization of my IDAT data. And here I have applied CSMA kind of normalization, min5, CSMA, these are normalization steps. So finally I got these values. So then this is what I mean about the data pre-processing. Or maybe when I am doing this, some values, maybe this value may be missing due to some experimental handling or something, or maybe there are some noises or the outliers. So maybe like it should be 0 to 1, but it's possible that when I'm doing the calculation, it could be 1.5 or 2. So that means it's a false. It's exactly the experiment has been failed. So I have to remove it, or I have to do something because it's false. It's not possible. So that is what I mean by data pre-processing.
Sir, Mike is okay, sir. My question was like, it is necessary to after splitting data, yeah, before splitting you have to do pre-processing of what is saying long transformation, these or that. So you have to do before splitting our data or after splitting.
Salman,
You are on mute.
unmute, sir. Salman, please unmute yourself.
Acha, I mean, before even applying all the code before machine learning, you have to, do this normalization, do this data pre-processing.
Okay, okay, sir. Thank you.
Yeah, even before applying, starting the machine learning. The data, before going to the machine learning, whatever, how much you could clean your data, it will give the best possible, prediction. It will give the best possible prediction. How much it is
Okay.
cleaned.
Okay, thank you, sir. Thank you.
Yeah.
Sir, can you please elaborate that grid defining?
Pardon?
Can you please elaborate that grid defining? Grid.
Grid defined. Okay, I'll explain it again. So we have got this result, okay? So we'll go with the result after this. So here in the few steps, I just have called what I need. So whenever you write the code, because when I first used to write the code from the scratch, I call it whatever I need. Then when the final step, whatever I have called, I just make it on the upper side. Okay, so this whatever we need, so we have called it. So there is a function like grid search as well as pipeline I have taken, because I'm not going to do it one by one. So I just make a pipeline. So in the pipeline, what I have done is in the pipeline, it has to call the function where it has to select the k-best based on the mutual info regression, as well as it is just using the model as a linear regression. Okay, if in the same code, if I have to do the other, I'll define a for loop and call few others model. So one time it will do on the linear regression, next time it will do on the ridge, next time it will do on the elastic net, and so this we have already seen yesterday, where I have called in the same coding, I have called 6 function in the same pipeline for the for loop. So here I applied the pipeline and I can define some other models also. Then I have defined the grid. So grid is here I have used the dictionary function of the Python coding. So I have defined two steps it has to call from the pipeline, which what it has used to fs select k-best method, and it has used to take the model. So both select k-best for each step of the model. If I have defined 2 models, so what it will do for each value of this, it will go with the linear regression as well as for the ridge also, but it will take time. So just I have chosen the one. So that means it has to take but one score function. It could be whatever I have defined, it will be in the next step. So from this, so we have the 100 features. So let's suppose if it is on the first feature, so on the first feature, it will run the linear regression model. Then it will on the second feature, it will run the linear regression model. Then on the third, combination of second, combination of 3, combination of 4. And you could assume the combination of 2 will be actually not the 2, but it will be the permutation combination of 2 into 100. It may be the first feature and the second, the first feature and the third, first feature and the 19th, first feature and the 100th. So you could assume how many will be the combination of 2 features. Similarly, how many could be the possible of the 81 features or 82 features, because it has to select from the 100, 81. So all the 81 should be the combination could come. So you just assume the numerics behind this line. So for this, I have just defined as grid cell. So this is the syntax. So x dot shape is whatever the shape of your data set. So it is 100 minus 20. I just want to execute from 80 to 100. So that's why I have taken. If I have to define from all, I'll just remove this. So it will do the 1 from 100. So all the combination from 1 from 100, but it will take more than an hour to execute. So just I have taken from 80 to 100. 20 combinations. 20 mean combinations. So mean for the 80 features, 81 features, 82 features, and the 100 features. And this is something what you got because it's 91 plus 1. So this is syntax to get the 100. So then I have applied the grid search CV. It's not searching, and it will score based on the negative mean squared error. Job will be done, and result it will fit this and then print the best image, best condition. So on all the combination, it has, let's see, from the 80 to 100, it has selected. So once it is taking the 80 features, so it will, what it has done here, it will select all the possible combination where it can select 80. So from the 100, it's possible which 20 you are excluding first. So all the possible 80 combination it has taken here. and make a model, and the best MAE it achieves is something around 50, which is very poor. And from the 81 to 100, you see this is what we are MAE achieving, and best MAE is it has already, I have scored it what best MAE I'm getting at the what best configuration. So that means in the 81 features, I'm getting the best MAE. So best configuration on the 81 features. So that means from that particular features, 81 are the most important features to build up the MAE. And you could see this MAE is just 0.01. So I just have type negative mean square. It's not, you could select positive mean square also. So this is how we select that and how we build the model. So finally, I'm just going to give it the 80 features. I'll add another code and it will select what 81 features are, and I will represent it. So that's all in this code. I hope it's clear.
Sir,
yeah,
that means earlier that you took 10 features and
yeah,
that 10 features are important, but here in this data, instead of 10 features, 81 features are important.
yeah. So
that
what
means
that does
earlier
mean,
that you did
yeah.
Earlier that you gave 10 features, it was random. That means we can
no.
Okay.
So that 10 feature was giving the highest score, but that was creating the impact on the negative manner. So that features were not important, were the least important.
These
You
were the
understood?
least important.
Yeah.
Okay.
These were, so from this graph, if we assume, so that means whatever
But
the
why
high
you
peaks,
why you took only 10? Means it could be 15.
it was just the random thing. It was just the random thing I did. It's just the
Okay.
random thing I did.
So if we
So
have to do, then we have to randomly take, or we have to try taking different
you have
number
to
of.
try taking differently. Yeah. So from
Okay.
this graph, my
Hmm.
first impression was all these high peaks are important one. This is the first
Okay.
impression. But when I have executed the model,
Okay.
it means these high peaks are the least important one. These are the most important one, which is the north peak. So this is another way around. Yeah.
Okay.
So that's what the assumption. Yeah.
Thank you.
If there are any further questions, I would happy to take. Otherwise, we'll end up.
Sir, how to deal with the predictions for which value falling near the threshold value of the features? How to deal with the predictions for which values falling near the threshold value of the features?
Or which value falling near the threshold value
Threshold
of the
value.
features. What do you mean by threshold value here?
Threshold value, for example, if you want to classify between the two classes, and below 5 is one class, after 5 is another class, 5 to 10, and some values. So for some data sets, for some data, values of the features falling near to 5, then how to deal with those predictions?
I think this is, you have asked about the classification model. What I have defined yesterday as in the linear regression as a gamma or the auto thing. So this is another way where you define or where you tune
your voice is breaking, Salman.
Okay, so what you have asked is a classification problem actually. So yesterday I have shown you with the code where I have defined the gamma value in one of the model as an auto. So it was automatically taking, but it's possible that you define some threshold value. So this is another way of tuning the feature. You put some random threshold values from whatever you want. Like in one of my project, I remember that I have just given the threshold value, and I have, like what I have done here as a grid search. So similarly on the Veka, by using Veka, I have done from 1 to 10, whatever the value I'm getting, and selecting on the what threshold I'm getting is actually the best value. I have given that particular model. So I mean, exactly you can't say. It's just you tune your model on some parameters and give that particular parameter. Okay, on this parameter, it is best possible to predict the things. So that's all I have to say about that.
Okay, so thank you.
Yeah.
Sir, because you have a lot of experience, like you did PhD, you did the PDF, and also being us new student, they starting the machine learning with the genomic data or gene data. So, is there any specific books there is like we can read on those things, sir. Because YouTube and things are lot of things available, sir. Everything available.
Yeah, yeah, a lot of things is available. Even you know, whenever I talk with the experimental biologist, although I have done, so what they assume that like I have to run the code. If I just give someone, if some experimental biologist will be sitting with me, he'll say, okay, you just have write the code within a day or two, and you just have executed it, and it's running in the background, and you will get the result. But it's not like that. For each function, there are 10 to 15 sub function. I have to try it. So my answer is that if it's as simple as you are thinking of it, so that means I have to publish the paper on the each alternate day. But it's not possible. You know, similarly,
Yes.
yeah, similarly, the experimental guys think they try, test. So in the same manner, we try test like initially I have done here as a mutual co-information. I mean, correlation, the correlation was giving the another way around. Then I have to rethink, okay, let's apply some other method. Let's apply some other methods. And for the book, actually, I didn't read any book. It's just that while discussion with, I mean, in the PhD, you got the mentor who used to teach you how to go with it. You get some seniors, and so I'm not aware of any such book or anything. I mean, it's just reading the research articles, review articles, not any.
Yeah, research article. What I'm saying, everything, lot of plenty of available things like YouTube, a lot of things.
Yes.
I think so, you need like basics books, and because sometime some not in background computer may some not background biological, so that is basic concept can especially the genomic gene data, so that it would be very useful for me especially, sir. So if any ideas are because you maybe the book lot of your group in that's your team maybe, so you can ask
Yeah,
from any.
I'll ask and I'll share with you. So for me, what my way of working is that I used to deal with the data and the problem, and then try to think what I can do into this. So that's, but it's not always, it's different from person to person how they choose. But yeah,
No.
I'll get some good tutorial or something.
No, sir, what you're saying is correct. Lot of things is coming, result is coming, coding is given, everything. But what is result is coming, how to explain, how to interpret it, that's sometimes very difficult to learn. So maybe from that, any literature or books can help, because paper is also a lot of paper people do that. Yes, sir. Okay, sir.
Yeah. Okay.
Thank you,
I'll
sir.
show you.
Excuse me, sir.
Yeah.
Sir, same question like Rakesh, sir. From there, we can get good research article related to machine learning. Actually, my background is chemistry, and I am interested in research structure-based machine learning model for drug discovery.
In the machine learning, I think there have been very good review articles in the machine learning and drug discovery.
Sir, I tried searching on Google, but unable to find.
Just mail me, and I'll try to search and will definitely get you. Just
yes, sir. Today I have mailed. Sir, today I have mailed.
So I have not checked my mail. I'm sorry for that.
Okay.
So just from this, I'll go to the lab and see the mails and definitely.
Sir, if this is possible for you, share please some 1 and 2 article.
Yeah. Oh,
thank
obviously.
you.
Okay.
So, sir, all sir is possible maybe.
Pardon?
To every participant, yeah, you can share.
Okay, so I'll share with the Decode Life host, and
yeah, copy same.
some basic machine starting with gene data, genomics, some papers can be very useful for us.
Okay, I'll share with the Decode Life host, and they'll share with me. Okay, that's
sure, sir.
So, Dr. Salman, it's all from your side today for today.
Yeah, it's all from my side from this workshop, and maybe in the next workshop I just have to take you, because it's not my expertise, that drug discovery and that thing. So it's all from my side. Yeah.
So now it's a lots of thanks for supporting lot of things. We're getting a lot of comment from you, like getting a lot of things.
Yeah, it's always, and I take it as a platform, because if you have taken the introductory lecture, I assume this platform as something where we could make a good networking. Everyone is something in the very beginning of their career, and we need some good networking, some good communication, some good collaborations. But always there is limitation. We are committed to do some jobs, and we are getting paid for it, so we have to manage our time schedule like that. but it's always, it's learning from both the side. I always learn from the guys, they ask the questions, and if you have some projects which is of my interest, if you have the mutual interest, we may look for the collaboration and whatever. It's always from both the side, and it's useful because in the workshop sometimes we get very highly educated, but their domain is quite different, but they are the expertise in their domain and we are very new into that domain. So sometimes it's very good communication and to learn the thing. So for me, I'm always open to that. I always prefer to look for it if I get some kind of collaboration, other things. So it's a humble request. If you have something like that where we could work on, it's always going to be a good thing. Yeah.
So most of the people are saying thanks to Dr. Salman for your sessions on machine learning and Linux, and we are really thankful to Dr. Salman for contributing excellent sessions on our platform despite his busy schedule. I know how much busy Dr. Salman is, but really we are very thankful that you are helping our cause of spreading affordable bioinformatics. So thanks, Dr. Salman, and without you we are not as good. So thanks, and please note the tomorrow is break, and day after tomorrow we have some sessions on genome-wide association studies. Also, registration is open for our upcoming bioinformatics workshop, that is drug development and discovery. Again, it will be affordable bioinformatics. We believe that you enjoyed this session of Dr. Salman, and soon you will see Dr. Salman in our upcoming workshop also. So if anyone want to say something, they can unmute and say, otherwise we will wrap up this session. So most have typed in the chat box. So Salman, can I end the session today?
Yeah. It's thank you so much. Thank you.
So
Have a good day, everyone.
And I will share all the relevant material from Salman with you as
Mostly
soon as possible.
I'll mail you within an hour. So I'll mail everything to you. And regarding the literature, just give me today time. I'll search for it, some good literature, and you will get by today or tomorrow surely. And whatever the quotes and other things, I'll mail everything within an hour. Yeah.
Okay, Salman. Thank you. Thank you, participants.